Today we will start with the second unit of the quantum chemistry, that is the approximate method, or what is known as the approximation method. So in this we will be dealing with the complicated systems, that is systems which are having more than one electron system. So when exact solution to the Schrödinger equation, you see, it cannot be found in complicated systems. So what we have done, we have used two methods. First one is the variational method and second is the perturbation theory. So in this video I will be starting with the variational method. When we talk about the variation theorem or variation method, it generally tells you about the ground state energy level without solving the Schrödinger wave equation. And it is specially applicable for the interest in the chemical problems. So let us try to see the Schrödinger wave equation. So this is the Schrödinger wave equation, that is del square psi plus 8 pi square m upon h square e minus v psi is equal to 0. Now what we will be doing is we will be rearranging this equation, that is the whole equation we will be multiplying by minus h square upon 8 pi square m. So let us see what we will get. So here I am multiplying del square psi by minus h square upon 8 pi square m. Similarly 8 pi square m h square, again I am multiplying by minus h square upon 8 pi square m. So this get cancelled. So what we are left with is minus h square upon 8 pi square m del square psi minus e minus v psi is equal to 0. Just open the bracket, you will get this equation. This part you will take that side, you will get it. Take psi common, so we are left with minus h square upon 8 pi square m del square plus v psi is equal to e psi. So this we can replace by this capital H. So final equation we will get h psi is equal to e psi. So this is the general equation which we write for Schrödinger wave equation. Now what we will be doing is we will be multiplying this equation by a complex conjugate of psi, that is psi star. So let us multiply it. We will get psi star h psi is equal to psi star e psi. So the above equation you will be again integrating. You will be integrating both the sides. So it will be integration of psi star h psi d tau is equal to psi star e psi d tau. So from this e, it is a constant that you will take outside, and from that you can find out this is the ground state energy. Now if you use normalization condition here, this portion, that is integration of psi star psi d tau, that will be 1. So what you will be getting is e will be equal to psi star h psi d tau. Now if let us say that this psi function, it is we are replacing it by another function, that is phi. So instead of psi you will be writing phi here. So this will be phi star h phi d tau and phi star phi d tau. So that energy we will be representing by this equation now, that is E phi is equal to this equation. So what it was observed that if you are replacing the function psi by another function, so this energy which you are getting, that should be either greater than or equal to the ground state energy. That is E phi, that should be equal to or greater than E naught, that is the ground state energy.